We're going to be talking about balancing polyatomics. So right now I'd pause the video, I'd write down this title, and I'd write down this equation, leave you some space, and write down this equation, because we're just going to go through these pretty quick. Alright, so this is going to be really similar to what we've been doing. I'm going to show you two different methods. I'm going to show you the one that you're really comfortable with for this top one, and then I'm going to show you one that you're a little bit less comfortable with for this bottom one. Alright, you can decide how you want to do them. So the first thing is we need to talk about what even a polyatomic is. So a polyatomic is an ion that's going to stay together throughout the reaction. So it's going to be the same on the left side and on the right side. So an example is going to be NO3. So you'll see that it's made up of two different elements, and they're going to be staying together on one side of the equation and on the other side of the equation. So I want you to pause the video and take a second to look at this top equation and try to find what two element combo stays together on this side and on this side. Alright, so pause the video, take a second to think about that. I'm going to keep moving on and I'm going to underline it for you. And so on this side, on the left side, you'll notice that you have SO4, and on your right side it stays together as SO4. So that's going to be really useful as we're writing out our list of elements, is knowing that we're going to keep SO4 together in one unit. So now let's write out our list of elements. I'll show you what I'm talking about. So we are going to have Al, Br, K, and then we're going to have SO4 as one thing together. And then on this side, we're going to have the same thing, Al, Br, K, and then SO4 as one thing together. Now, you can pause the video right now to fill out these numbers and then double check with what I write, but on this side we're going to have 1 Al, we're going to have 3 BRs, remember the little number here tells you, we're going to have 2 Ks, and now the SO4 is the hard part. So we're going to look how many SO4s we have total. Lots of people want to say 4 because they see this number right here and they want to say 4, but we need to look at SO4 as a whole thing and how many of those whole SO4s do we have. And so you'll notice that we only have one SO4. Now if we do the other side, we have 1 Al, 1 Br, 1 K, and now if we look at our SO4s, you'll notice that we have the parenthesis and we have the 3 on the outside. So this little 3 here tells us that now we have 3 SO4s on that side. So you'll notice if it's something that doesn't have any parentheses or numbers, it's going to be 1. If it has parentheses with a little number, it's going to be whatever that number is. In this case, it's 3. So now let's finish balancing this equation. So Al is 1 and 1, that works. Br is 3, so we need to times this side by 3 to get 3 over here. Make sure we put our 3 in up top. Oh, sorry, actually, we're going to go back. I'm sorry about this, guys. Because I didn't realize that we actually missed a 2 here by this Al. So that's going to kind of change our stuff. I'm sorry if you have this all written down already. But this Al is now going to be a 2, not a 1. So now if we look at our equation, Al is 1 and Al is 2 on the other side, so we have to times this by 2 here. We get 2. Remember to put your 2 up front. Now if you multiply that in, you notice, remember you have to do it to your Al and your Br3. So we have to times our Br3 by 2, and we get 6. So now if we look at our Br, so our Als are 2 and 2. So now let's look at our Brs. So we have 6, so we have to times this by 6 to get 6. And we're going to put our 6 up here by our K. Br. So we already did 6 to the Br. We also need to do 6 to the K. So let's multiply that by 6 and we get 6. If we look at our K on this side, on our left side it's 2. So we have to multiply this by 3 to get 6. Since we multiplied it by 3, we have to put it up top. We did 3 to the K2. We need to do 3 also to the SO4. So we times this by 3 and we get 3. So you'll see now we have 2 and 2, 6 and 6, 6 and 6, 3 and 3. So that's how you do these, really similar. You just have to remember to keep your polyatomic ion together. Now if we do this one down here, I'm going to do it a little bit different of a way. Instead of writing this whole thing out and writing all these elements down, you're welcome to do that. I'm going to keep them together and I'm just going to look at it and try to figure it out. Now first let's figure out your polyatomic ions. So pause the video, try to write them down. This one there's actually going to be 2, so make sure you have 2 that you underlined. Alright, I'm going to show you. We have Cn on this side, we have Cn over here, so that's 1, and then we have the SO4 again, both these places. All right, so now, like I said, we're not going to write out the whole list. You're welcome, you know, to write H and CN and CU and SO4 and do that whole thing. You're welcome to do that. I'm just going to look at this problem and try to figure it out. So I'm going to say, on this side, I have 1H. This side, I have 2H. So what number do I need to put here to get this side to be 2 H's? I need to put a 2, right? All right, so we did our H's. We have 2 H's and we have 2 H's. Now, on this side, I have the 2 goes with the CN also, so I have 2 CNs. On this side, I also have 2 CNs. That little number tells me 2 CNs. Then I have 1 CU, 1 CU, 1 SO4, 1 SO4. So this is balanced just like that with just adding that number up top. So you can do them kind of in your head and work out the problems that way. Anyways, I hope this video was helpful. The worksheet's super short, so try to finish that. Please email me if you have any questions. Good luck finishing it all. Bye.